The plane, like all geometric surfaces, is unlimited. The position of the plane in space is determined in different ways. We can set the position of the plane in a space, first of all, with 3 points that do not lie on the same straight line. You can see this example on our drawing. We have 3 different points, A, B, and C, on the horizontal projecting plane and on the frontal projecting plane. We also have the same projection of the same points, A1, B1, C1. In the majority of such points, we can consider, for example, like the vertices of triangle. We can connect these points and get the triangle. We also can set a position, a location of the plane in space with the help of straight line and a point, like it is shown on this drawing. We have a straight line AB and a point taken outside the straight line. As you see, we can connect these 3 points, and again we can get the triangle ABC. So we can set the position, the location of a plane in space with the help of 3 points, and the second with the help of a line and a point outside this line. The third method, we can set the position of a plane in a space with the help of 2 intersecting straight lines. It is shown on this drawing. As you understand, the intersecting lines are straight lines that are located on the same plane and have the intersection point. On this drawing, we have 2 intersecting lines, AB and CD. We show these lines on horizontal projecting planes, AB, CD, and on frontal projecting planes, plane A1, B1, C1, D1. And here on this drawing, you can see the thin straight lines with an arrows. It is communication lines. With the help of these lines, we can project the point from one plane to another projecting plane. What else can I add to this drawing? Again, we can connect points, for example, AD and CD, and we will get in this case 2 triangles. So you need to remember that to set the position of a plane in a space, you can do it with the help of triangle. And the last, we can set the location of a plane in a space by 2 parallel straight lines. These 2 straight lines should also lie on the same plane. As it is shown on our drawing, we have line AB and parallel to it line CD. And again, with the help of the communicating lines, we project the points A, B, C, D from the horizontal plane on the frontal plane. Communicating lines is shown on our drawing like the straight thin lines with arrows. each of the listed plane tasks can be converted to another from this list. For example, by connecting 2 points, we get a plane set not with 3 points, but with a straight line and a point. From this example of setting a plane, you can move to the next one if you draw a line parallel to a line or intersecting this line through the point. And now let us find out how to construct a line in the drawing that lies in a given plane. This construction is based on 2 positions known from geometry. The first, a straight line belongs to a plane if it passes through 2 points belonging to the given plane. Let us consider an example on this drawing. Let the plane Q1 be defined by 2 intersecting lines. Our left drawing AB and CB, and on the plane Q2, the plane is defined by 2 parallel lines DE and FG. On each of the given lines, you can take 1 point. 1 point on the line AB, 1 point on the line BC, and the same 1 point on the line DE and 1 point on the line FG. By connecting these points, we can get straight lines, and we get that these lines intersect the lines defining the plane. So, on our first example, on the example with the straight lines AB and BC, we get 2 intersection pairs of lines. One pair is AB intersects with a new constructed line. And the second, the straight line BC intersects with a new constructed line. We have another type of setting the plane in a space. On our second plane Q2, we have the line DE intersects with a new constructing line. And the line FG intersects also with a new constructing line. We have another set of a location of a plane in a space. So, this new, just now constructed line is located in this plane, as you understand. And we have different forms or different types of setting the plane in the position of a plane or the location of a plane in a space. The second example. The second position, it is shown on this drawing, and the second geometrical rule. A straight line belongs to a plane if it passes through a point belonging to this plane and is parallel to a straight line located in this plane or parallel to it. On this drawing, we have a straight line BC and a point outside this line point A. We know the rule that when we have a straight line and a point, we can set the location of a plane in space. Then we construct a line, a new line that passes through point A and is parallel to the given line BC. So, if on the plane P, this plane is denoted like P, if on the plane P through the point A drew a line parallel to the BC, then this new drawn line will also belong to the plane P. Our second rule also is completed. And now let us understand how to construct a point in the drawing that lies in a given plane. To do this, first we need to construct a straight line that lies in a given plane, and then we take a point on this straight line. On this drawing, we need to find the frontal projection of a point D. So we have horizontal point, we have horizontal plane, and on this horizontal plane is defined by 3 points A, B, C. And we have a point outside the lines that constructed this triangle. We have a point D. This point D also belongs to this plane, horizontal plane. We know the horizontal projection of the plane D. It is located on horizontal plane. And we also know that point D must lie in the plane defined by the triangle ABC, also on horizontal plane. Now look on this drawing. To perform these conditions, you first need to construct a horizontal projection of the line. The straight line must be drawn so that the point D belongs to this line, and the line itself must be located in a given plane. To do this, draw a straight line through the points D and the vertex of our triangle, point A. The line intersects the side, the opposite to the vertex A side of triangle CD in the point M. With the help of communication lines, on our drawing, these lines are thin lines with an arrows. We project all the points from the horizontal plane on the frontal projection plane. So, first of all, we need to construct the shape of our triangle. And on the frontal plane, we get a new triangle A1, C1, B1. It's the projection of our triangle ABC on the frontal plane. Then we can project point M, because point M on the horizontal plane is located on the segment on the side of triangle CD. It means that on the frontal plane, this point also will be located on the same side of triangle. So with the help of communication line, we project this point M, from the horizontal plane to the frontal plane and get on the side C1, B1, the projection of point M, it will be point M1. Now, we know that our point D on horizontal plane belongs to the straight line that connect points A and M. So, on the frontal plane, we also need to connect points A1 and M1 and continue this straight line. On the continuation of this straight line, we can get the projection of point D on the frontal plane. For this, we should construct communicating with the help of communicating line, we should project point D on this line. Because you know the rule that if point belongs to a line on one projection, it should belongs to a line on the second projection, because this point is lying on this line in space. So, on this example, on this drawing, we show how to find the points outside the given plane and project these points from one projection plane to another projection plane.